He said we all will fail it. Both exams will be.
See, only this current semester we will conduct. That's what is our plan from our side. Current semester, the one what it is now. Right now you are in fourth semester now.
Yes, ma'am.
So fourth semester
Yes,
we
ma'am.
will try to conduct. But third semester I don't. We are not thinking about it. We are really not thinking about that. Because it is difficult also to get, and then maybe assignments and all are there, no? So we might take up some logic behind it, just like some formula just for fourth semester and third semester together. That formula is there, no?
Yeah, ma'am.
So maybe
Yes, ma'am.
like last time for second semester we have done that. So third and fourth semester, for fourth semester we will conduct and make the third semester just exactly like that. Something we have to plan. See, this is all the propositions from faculty side. Most 80% faculty has proposed, but let's see what will happen. We will discuss. Some people vehemently oppose. I don't know why. Okay. Difficult to
Ma'am, because they are
understand.
enjoying
Sometimes I seriously don't understand. Yeah,
because they are
go ahead.
enjoying living in house.
Who we? Hey, I don't really enjoy. I hate. Every day I used to come to campus. Like it's very difficult. Not living in house. What in that four walls we can do, yeah? How much cleaning we will do and how much research we can do. We can't even think a new idea, can't promote, like if at all we don't have people to talk and discuss. I don't know. I am in like this zone. So by this time you could understand, like I do blah blah most of the time. Right? So anyway, so I have seen some postings of the previous classes. Right? So what are your input, analysis? You also have seen? Yes or no? People have seen or not? Some postings by, just a second, Swapnil has given, I am going from back side. Right? Not only Swapnil, we have Swaroop, we have Salangna Behra, then who else? So many has given. See, Swaroop has given, then Hiranmai has given. Right? So in CRISP, so the problem is that time what I have told, you can directly take a big multiplexer and design. That is point number one. That means you fix the inputs, right? Second option is you can take some control input variables, data variables, and you can reduce the burden, right? Like what? How many variable you have planned? What is the size of that? Hello? Am I in a meeting or not?
5 variables, sir.
Yeah, 5 variables. No, that's what I meant. So, 5 variable means you want 16:1 marks. That is 1 point. Correct?
Yes, ma'am.
So that is one direct way. If at all not 16:1, you can break into pieces like small cascaded form. So in that, some have proposed so differently. Like, see, for example, I'm just pointing out, no offense. Everybody read very nicely. Some people have given one boy, especially. Wait. I think that day itself he is posted towards the night. Who's that? I'm not remembering. And I'm missing that. Anything has been removed? No. Yeah. Hiranmai. Yeah. Hiranmai has proposed one thing. Can anybody see Hiranmai's posting? Just a second. Let me share. Just a second. So I'm just taking from here itself directly and should I zoom? Yeah. So if you can see what he did is he tried to make some other variables. If you can look into that. Yes, anybody can see? Everybody can see or not?
Yes, ma'am.
Yeah. What is the size of this Hiranmai? If he is in the meeting, he can answer. He or she? I don't know. Sorry.
Yeah, I am present.
Yes, no. What is the size of that?
Is 16 cross 1.
Yeah, that is 16 cross 1, but afterwards you have done a cascaded mode. Correct. So each mux size is what?
4 by 1.
Okay, 4 by 1. Very good. So what prompted you to take DE there? Why did you take DE there? Why can't it be AB? Hello?
In this
I'm so sorry, I'm not able to hear.
no, and that I have rounded in the 16 cross 1 marks.
That's what I understood. You have written there. Why like that? Why did you point out like that? Why did you point out like that? Okay. Anyway, in general, let me discuss. Okay, regarding that problem. You have one 16 cross 1 marks. Sorry, 16:1 marks. Fine. And you have 16 inputs. 16 inputs. To control that, you will have how many? 2 power 4, no? So 4 select lines. Yes or not? Everyone. So
Yes.
now this 16 by 1 marks has to be cascaded by 4:1. Right. So if 4:1 is there, definitely you require 2 select lines, common select lines. Just like the previous one what I have shown. Right. So you can take any variables as select lines. So it can be AB or BC or DE or CD or DE. Is that correct? Any point. Then afterwards, accordingly, you can take this. Then the next one will be its outputs. Okay, you can consider another marks here and then take the final one, taking some other select lines. Is that possible to attach this? Anyway, I will post the answer also. Somebody has done another answer. I have not remembered that, but somebody have done also. Everybody has tried in this manner. This is good. This is 100% correct. This everybody might have tried. Is that correct?
Correct, ma'am.
Yes, ma'am.
This
Yes.
is just an alternative plan. This is an alternative plan because we are engineers, so we have to think alternatives, right? So we can make a common variables, right? I'm already giving the clue. Those who have not done, please go and revisit it. So common variables as the control inputs or the select lines we can say, and then the rest of the things you can attach for other variables. Then after 4:1. Still execute that, and if at all the function is coming, fine. Otherwise, maybe after this summation can be another marks also you can use 4:1, or you can use or 4:1 is better. Yeah. So another 4:1 marks. Summing up all these outputs, we can control it, and the final function can be given. This is a skeleton. So think in this manner and try to complete. So if at all today you can complete, post it. Otherwise, today night I will post the what? Solution of this. Okay? Is that fine? Am I in
Yes,
the meeting?
ma'am.
Yeah. Okay.
Yes.
Okay. So now, today I was just thinking, since you have studied analog electronics, right? So I don't want to take away digital electronics from analog electronics because it's also a version of that, right? So in your analog electronics, anytime did you compare two signals? Yes or no? Comparison of signals means what? Definitely signal means what? Two signals. It can be amplitude and frequency wise. Yes. So consider I am taking two signals for comparison. Signal A and signal B. Right. This is one signal. This is another signal. Right. So amplitude wise, I have three options. A signal can be equal to B signal. A signal can be less than B signal, and otherwise A signal can be greater than B signal. Is that correct? Amplitude wise. Frequency constant. Now itself I am clarifying. A and B are for two big signals. A and B. Is this possible? These are the possibilities or anything else? Yes, why you people are silent today?
That's all.
Yes, ma'am.
These are the possibilities. Okay, now if at all I have a op-amp, I have a comparator, and I can nicely design and say whether the A signal amplitude is more or less. Is that correct? But unfortunately, I don't have a comparator. Sorry, I don't have a op-amp or do anything. And what I will do is I will try to work out in a digital mode. Okay, so I will have A and B as a digital signal and try to compare it. Okay, now if I take the A signal and a B signal as a digital wise, like 4 bits can be used to represent that. Like for example, my A is there. I'm directly giving a numerator. Okay, in green I'm using. A is. Now tell me in which category it falls. 4 bits. Each means A is a signal, B is a signal which is comprises of 4 bits. That means it can be represented in 4 bits, maybe repetition mode. Forget about that. So these are the 2 signals. Right. So in which category it will fall?
A less than
Second category.
Second category. Why? Why? How did you do that?
Because, ma'am, if we try comparing, we try to compare from most significant bit. So
Okay.
while comparing, the first most significant is same. After that, in A it's 0 and in B it's 1. So A is smaller.
Okay. So you started off with the most significant bit and did. Very good. But if the sequence is too lengthy, let us consider I have some 300 bits with me. So then also we have to have some generalized thing, generalized setup. So I wanted to design now very quickly. My objective is to design a magnitude comparator of 2 digital signals. Right? Let us consider it is 4 bit or 10 bit or 20 bit, doesn't matter at all. But I want to compare 2 digital signals and say it is this or this or this. That will be my output. Did you understand my objective? Right. So in that case, my design, it's a combination circuit now, because you already mentioned the procedure. You started with most significant. What did you do? You tried to find out whether these 2 are same or not. Since it is same, you move to this one. So then you compared this. Right. Then afterwards here A is less than B has come. 0, this is 1. So 0 is less than 1. So obviously then you concluded definitely whatever rest will be there, A should be less than B, because the third place or maybe the next to most significant bit has shown a lesser one. Is that the logic?
Yes, ma'am.
Okay. That means first thing is you should verify this, right? Then afterwards, once this is through, then you have to move to the next 2 options. Is that correct? Yes or not?
Yes, ma'am.
Right. So now this is what I want. Now let us consider, please take down. Design a magnitude comparator. Design a magnitude comparator circuit. Okay. Right. Design a magnitude comparator circuit that will compare two binary sequences. Two binary sequences, each of 4 bits, each one consisting of 4 bits. Okay, now this is our option. I will go very specifically, very slowly. Okay, because my objective is now limited only to 4 bits. This is just an example I have taken. Now, If at all I will start taking exclusively what I have mentioned in the statement. So my A equal to, I have 4 bits. So as a practice, I will start noting them because they are generalized. B1, B2, B3. Okay, now clearly first and foremost thing is, okay, if, okay, A3 equal to B3, A2 equal to B2, A1 equal to B1, A0 equal to B0, then A equal to B. This is very clearly understood. Every bit, if they are equal, then I can say A equal to B. Is that correct or not? Yes or no?
Yes, ma'am. Yes, ma'am.
Yes,
So, then these numbers are binary digits, right? If they are 1 or 0. Okay, 1 or 0 is there, right? Which means 1 or 0s will be there now. Okay, so how can we represent this or express this logically so that I can have an indication what the output should be? Like, for example, can I use some gates?
Ma'am,
Gates
it can be XOR gate, ma'am.
And XNOR
It
gate.
was XOR.
Yeah, that's what I'm telling. So can we use logically some indication that these bits are equal? So one has proposed XNOR. Like, who has proposed XNOR? Can just tell me what is the logic behind it. Then afterwards I'll go to XOR. Okay, some has proposed XNOR. What is that you wanted to think?
Ma'am, because in XNOR circuit, when A and B both are equal, either both are 0 or both are equals to 1, then the output is 1 1, ma'am. In other case it is 0. That's why.
So
XNOR
now whatever. May I know your name, please?
Ma'am, Sankalp.
Sankalp. Okay. Sankalp's idea is what he is telling. Let's revisit what is the truth table of a XNOR. Okay. So AB is there. Oh, sorry, I will not use AB. XY. So is this exclusive NOR? No, you told. Okay. This is the exclusive. Right. So we will have 0 0 0 1 1 0 1. Okay. So these two cases you have like this. That's what you are telling, Sankalp?
Yes, ma'am. Yes, ma'am.
Is that correct? This is the truth table. Everybody agrees? See, what is this one? So try to verify. Please, I am going to the very basic electronics. Is that correct?
Yes, ma'am.
True? Okay. So what Sankalp is telling, I am decoding. What is that? If both the bits are same, it is word called same or equal, output is 1. Please note down that. That is what his concept is. What he is telling? Output is 1 when both the bits are same. If both the bits are different, output is different. Is it 0? Is this 0 both?
Yes, ma'am. Both are 0.
Okay. So
Yes, ma'am.
he encashed the equality. Is these two are same, then these are 1. That means if at all I will take that concept logic into this one. If I take this concept, that means what I am trying to take is I will take I equal to 0, 1, 2, 3. This is what Sankalp told in crisp. Everybody agrees for this? This xi means is the logic behind the equality, which is borrowed from the XNOR term or XNOR operation and extended to 4 bits. Why? Because I have 4 bits. Is this okay? Then only if it is 1, then so my A equal to B is nothing but X0, X1, x2, x3. All 1. Is all will be counted. Yes or not? Are you people understanding this?
Yes, ma'am.
Correct? So if anybody has any doubt here, please try to verify. This is one procedure I was telling. Because for me every bit has to be same. Then only I can say A equal to B. This is simple 4-bit example. Okay, so I have to do all the end combination. If it is equal to 1, definitely my total A equal to B. Is that okay?
Ma'am, half board is not visible.
Are you bro? I'm so sorry. Just a second. Let me see. Which board is not visible, ma'am?
Ma'am, little to the right. If you
Okay.
Bottom right, yes.
That's fine. Now top one, huh?
Yes, ma'am, it's fine.
yes, ma'am.
Now you see. Now this is idea of Sankalp. So which I have decoded and kept in logical way. Sankalp, are you satisfied? This is what you wanted to tell?
Yes, ma'am. Yes, ma'am.
Okay. So his idea is, let's go from bit by bit from the most significant bit. First thing is I have to verify whether they are equal or not, borrowed from the concept of this. Right? So I have take I equal to 0, 1, 2, 3, and then if A equal to B means this all has to be equal to 1 and combination. Is that correct? Yes or no?
Yes, ma'am.
Okay. Now somebody has prompted Zod. Now can I listen from him?
Yes, ma'am.
Yeah. Who is that?
I'm Tanishq.
Tanish. Okay. So now let's go with Zod. Should I erase it? Because digital means designs. Everybody can have a different ideas. No problem. So let's go with Zod. So you are saying with the Zod, erasing all these things. Okay. Okay. Now tell me, what is the Zod output? Zod means what?
0, 1, 1, 0.
0, 1, 1, 0. So what he told, if at all XOR operation you are taking, his mentioning is if they are same, output is always 0. Is that correct?
Yes, ma'am.
Yeah. So he went with 0, 0, 1. No problem. It's good only. So we can take the same concept, xi equal to, what is that? I can say, should I write everything? So no, I will write it should be equal to 0. A equal to B means output should be 0 if they are same. Is that correct?
Yes, ma'am.
Everyone. So xi means that is what. So we can rather okay. Is that okay? Fine. See, both the logics are correct. If this A equal to B, if this operation is done and output is 0, we can conclude A equal to B. If we use XNOR operation and the output is equal to 1, we can conclude A equal to B. Both the cases, it's fine. Everybody agreed? Yes or no?
Yes, ma'am.
Sure? Okay. Now A equal to B is very easily done. Our magnitude comparator can take up the first job of comparing equality. So if the comparison equal fails, we have to proceed further. So let's go with the NOR. Then afterwards we will do with XOR. Okay. So let's consider the NOR operation first and we will create the magnitude comparator. So consider we have a NOR. Okay, right, is equal to 1. Then we will conclude this. That is the conclusion. Right, if this fails, If this fails, I am going with XNOR operation first. Afterwards, the design I will change. XNOR operation. Everybody, please try to understand. Right? So now this is not satisfying. So I have to get either this category or this category. Is that correct? Now my next two options are these two only, na? Is that correct or not? Everyone?
Yes, ma'am.
Yes. Now tell me how we can go now. Think about that. If that one failed, so A greater than B. To determine whether A is greater than or less than B, what we should do? So we have to go for relative magnitudes at every positions. Yes or not? Everyone. From most significant bit, that's what the problem. I don't know, first one, Samay, I think, who has told. First, we will start with the relative magnitude from the most significant bit. If there what equality is there, then we will jump to the next one. Then if equality is not there, then we will conclude it is greater or lesser. That's what, no?
Yes, ma'am.
Yes, ma'am.
So how we are
Yes,
going to
ma'am. Yes,
verify?
ma'am.
How we are going to verify that? Okay, now let me start. Let me start from this. Okay, I'll start doing this. This is complement and complement, the SOP format I am saying. X3, X2. I am moving this side. Is that fine? This will satisfy? In the XNOR format. Please think. There might be wrong also.
Ma'am,
Yeah.
we can design circuit as like uh, we will check for A and B if we'll OR gate or AND gate. So we'll get idea that someone is like A or B is greater.
Yeah.
So after that we will take a reference signal like one or
Yes.
zero. Then we will take one A with that reference signal and B with that reference signal. And if we got say for and if we got 1 1, so it will be 1 and 1 0 it will be 0. So from that we can say which is greater and which is less. And the second,
I think I did the same thing.
so
I took an AND gate.
where like but where is the reference signal? We have to come.
That is what the reference signal will always be fixed. We cannot show that in this one. Yeah.
Okay. And the second thing
this
can
is
be
now logical. Just a second. Let me come. We are trying to logically express. When we go to the experimental setup, we will have the reference signal. Obviously, VCC will be there. Obviously.
Okay.
So otherwise, see, even in your op-amp, if at all you take, we do have a reference signal, a thresholding signal. That is
for
fixed.
comparator circuit.
Yeah, that's always will be there. See, our designs pen and paper will be always with a fixed values, taking some references, taking some conditions. That is always there, but we cannot show that in the paper. In experimental mode, we can show. So
Okay,
this is digital design with pen and paper, not experimentally. This is the ideas we are taking. Is that correct? So I also took the same thing what you are explaining, but I logically expressed A3 and B3 dash. Obviously in SOP, that's what I was telling. So it is 1 and this will be 0. So this is concluded that A greater than B. Then afterwards, if these two are same, then we will go to the next bits. A2 and B2 dash. If in the A2 section also A2 and B2 they are same, then A3 is same, B3 is same, A2 is same and B2 is same. Then we will move to the third bit. Correct? Then afterwards, if these three satisfy, then we will move to the fourth bit. Is that correct? Think logically. See, step by step, it's like this. This is A, this is B. See,
Yes, ma'am. Ma'am, we can use a adder circuit also.
Yeah.
If we'll get,
Just a second. After this, now you see how many different varieties of comparators are there. See, it is not a hard and fast rule. I will use only this. These are a combinational circuits. You can use anything. You can use adder circuits. You can use, in fact, multiplier circuits also. You can use. So many varieties are there. I am not denying it. Let me complete this. Then afterwards, I'll listen to your designs. Okay. So A greater than B, I will take this. A less than B. Definitely just the opposite. Is that correct? Will you take like that or not?
Yes, ma'am.
Just the opposite of that, because we will go with the AND concept only and the XOR. Sorry, and the XNOR option. See, this is one of the simplest designs I am telling. Okay, I am not saying you follow this. This is just one idea. Even with the XOR also we have seen how to find out A equal to B. Then we can find out what is A greater than B and A less than B also we can find out. Don't we? Yes, at this condition, this should be equal to 1. This system has to be satisfied. If A is less than B, this condition has to be satisfied. So, we are finding out an F, which is supposed to be 1 for either this condition or this condition. Then only we can say A greater than B or A less than B or A equal to B. Something or the other has to be high. Yes or no? Then all the outputs we can combine and AND combination we can take and give. Is that fine? Is that correct or not?
Yes, ma'am.
Yes.
So you can as well take up a diagram for this. Then you can take the inputs A1, A2, A3, A4. Then calculate the interim X0, X1, X2, X3. Then afterwards find out the what is that? AND gate combination. Then afterwards you can do all of them and then give the output F equal to A greater than B greater than C, this one. So your combinational circuit will be having 3 outputs. Okay, 3 outputs. A greater than B, A equal to B, A less than B. This is your function. Either one of that will grow. So intermediate you will have the calculations. See, you have how many inputs? Because I have fixed it. So 1, 2, 3, 4, 5, 6, 7, 8. So A0, B0, A1, B1, A2, B2, A3, B3. Otherwise, you can give a set of A and set of B and then push them. So you will have some X0, X1, X2, X3 intermediate. Right, then afterwards collected and then given as 3 outputs. This is not any multiplexer or anything. It's just a combination circuit using different gate system and providing a task. And objective is to find out which is magnitude is more and which magnitude is less. Right? Now, if at all I take the same logic with X or, right? Will the equations be same or it will be different? Equations will be same only, I think, right? But output F should be glowing or off. Logic will be different. Yes, that's it. Just the opposite logic. That means F will be in the XNOR gate, it will be glowing. That means it is at high end. When XOR operation you are taking, it will be at low end. It doesn't matter. It's an indication. Is that correct?
Yes, ma'am.
Correct? Yes. Now you are free to give me the ideas. Now these are basic gates I have used. Only digital gates I have used. Somebody is telling we can use adder. So can you just elaborate on that? Yes, somebody? I don't remember their name.
Adder circuit can be used like we will add to we will subtract both the inputs by adder circuit by taking
Okay.
complement of 1,
Okay.
and after that when we'll get carry 1, then the subtraction is negative as we have studied, and if we'll get carry 0, carry 0 means and sum should be non-zero in both the
Okay.
cases.
So you will have a check on the carries. That's what, na?
Carries, and I'll get carry 0, then
Just a second. Everyone, please do concentrate on the explanation, right? Then afterwards we can have a discussion. In live classes, seriously, I used to have fights in the class because some proposes, some design, some opposes. It will be very interesting. Okay. First of all, somebody idea if they are proposing, try to visualize how different is your idea onto that. Please try to understand because digital is about logical thinking. Right. Now please go ahead. Sorry, I'm interrupting. Yeah, go ahead. So you will have a check on the carry.
0,
yes.
If we'll get carry 0, then I'll check the sum. If I'll get sum 0, then they are equal. And if sum is non-zero, they are not equal.
Okay. So you are trying to use adders for that because adders are already available. That's what, instead of using very basic gates.
No, we can use. You can we can use that circuit as adder also and comparator also. No need to make two different circuits.
Half adder ICs are already available. Full adder ICs are also available. So what? Your name is Herman?
Hassan.
So who was telling? Hassan. Hassan is telling?
Yes.
Who has given the idea? This idea. Just now we are
Hassan.
Okay. Hassan. So Hassan idea is why can't we use the same half adder circuit for a magnitude comparator also? Is that correct, Hassan?
Yes, ma'am.
Yeah, that's good. Very good. So it's a dual purpose. Very good. So anybody has any idea? Abhijit? There are 108 people just now sitting or don't know. God knows. But are they really participating? Aditi? Amrit? So many are there. So no other clue? Ranjit is showing. Ranjit is outside. What he is doing, Ranjit? You are playing or what, Ranjit? Okay. Who is this? Ranjit Ranjan Giri. Okay. So what Ranjit is doing outside? Outdoor he is there. Okay, no problem. Then Ishan. What happened? Why everybody? Madhusmita. Madhusmita, you have a senior Madhusmita also, but she is very nice. Why Madhusmita is very silent? Her name is also Madhusmita.
Yes, ma'am, I'm here.
You have an idea? Like you know who is Madhusmita Bari?
No.
No, you have a senior dual degree. She is very nice and very talented girl. Control automation, one of the topper, and she got internship also. And then she is based in Bells, right? And very hard worker. Okay, so Madhusmita used to fight a lot in the digital classes, if I remember, with Vishwajit and who else is there? Santosh Patra. These are all good legends, ma. Your seniors. Right, you can take examples like they are very good, very nice people, good. So who else is there? But Madhusmita, this Madhusmita is very silent, very bad. Lokesh. So what Lokesh is doing? Then Nitin.
Yes, ma'am.
Lokesh is doing what? No idea. The same idea. Hassan has given an idea. He told that we can use the adder circuit for both purposes. Yes, well done. Good. Then Sarad Das. So, okay, listen. With the multiplexer, can we do anything? Nothing? Forget it, ma'am. Multiplexer is of no use, huh? Right. Okay, so now this is just an example. Today I have taken a combinational circuit of a magnetic conductor. So we can go further for so many examples like this. In between, I will be giving you some well-noted combinational circuits like this. Okay, so after this combinational circuit which we have designed, I want to introduce one word called decoder circuit. Okay, so word is very familiar, decoder. What is decoder? Today in the class I was mentioning I will decode and tell. What some X has told, I decoded and told. Right? Sankalp has told something, then afterwards Samay has told. So their ideas I'm decoding and telling in a different manner. Yes, so what is that decoding means? So for example, if at all we have some bits of information, okay, and then we will try to put in distinct channels. Please try to understand. I have some bits of information and I wanted to expand them and put it in different channels. So you already might have got the clue. I am trying to take some n bits and then elaborate them into different versions, okay, of 2 power n. Right? 2 power n coded format. So this is my decoder. This is what a decoder does. N to 2 power n. Right? You already have faced this type of things. If 3-bit variable is there, how many ways we can code them? 8, na? Yes or not? See, just imagine each this A, B, C, there are only 3 bits. Consider 3 bits are there, different variables are there. So how many extreme, different, am I in the meeting or I am wrong? I'm there, right?
Yes, ma'am.
Okay. So if at all 3 bits are there, I can code them and put it in different channels in a coded format, and that too they are distinct. Are you getting the point? This is what a decoder is. A decoder is this. You should have a distinct outputs from a common inputs. Did you understand this? Now where it is used afterwards I will tell. But such a system is very much very much applicable and very much utilized for what I should say. For communication purpose it is very much used. Right, normal communication purpose. A small bits coded in different sequences and then put in different channels. Right? Did you understand here what is a decoder means? Decoder is nothing but a input which we are trying to keep it in different lines. So n input lines, maximum of 2 power n unique combinations will come out, output lines. So this is what called a decoder is. Right? So now for example, let me tell you why it is used. Okay, now everybody might have seen, everybody will tell the same example mostly. Did you know the 7-segment display? Right, this LED is glowing, which will be in the form of 8. You know this? You have an idea?
Yes, ma'am.
Right. So now I want to lit these LEDs, glow this one. Right. Now I want to have a control inputs. Right. So in order to light this, every time each LED has to glow, I should have 8 switches. Is that correct? 8 switches, no? 1, 2, 3, 4, 5, 6. Sorry. 1, 2, 3, 4, 5, 6, 7. 7 switches. 7. Okay. 7 switches are there, but unfortunately we will have a dot also. So another light. So total 8. Okay, so this is what the 7-segment display looks. We will have a dot also next to it. So we totally require 8 switches. So now to control that 8 switches manually, what I will be doing? I will be doing tick tock, tick tock, tick tock for every light to glow. Instead, if I use some wiring system, right, such that all these things can be controlled by only 3 switches. Carefully understand. Only 3 switches can solve the purpose. But I will give the wiring connections like that. Right? How I will do? Just see. I have X, Y, Z. Right? So these three switches will go, enter into a system, magical system. Right? Whose outputs are 8. Right? And these are wired and connected. I'm so sorry, Maviji, people. So if they are wired and connected to these systems, class, have another one plus I'm so sorry. If such a system is there, okay. Now this is D0, D1, D2, D3, D4, D5, D6, D7. Okay, so 8 values, right? And now, see why I am giving a resistance, you know, because LEDs, na? So I should treat them as LEDs only. Potential drop should be there. Yes or no? Finally, they are analog devices, na? Are you understanding?
Yes, ma'am.
Who is understanding? Only Shweta is responding. Why no other girl will talk to me or not? They are energetic to me.
Yes, ma'am.
Okay, you are energetic. Thank you. Okay, this right. So these all are connected, right? So I will send a code here. Clear. So when I select something, that one has to, among this only one code should go. Like for example, I will apply 0, 0, 0. That means all the switches are off. So immediately this information has to pass to this one. So D0 will be activated and that will be glowing this. Clearly understand. So another one is I will switch off this and on this. Right? So what should be there? This one, this combination has to activate this. That's what I gave the notations also like that. Very purposely. So D1. So that means this will glow. Like that, different D1, 0. That means it is like a D2, no? So D2 has to be activated and this will glow. Now, I am taking manually only 3 switches, if you remember. So manually I will change 3 switches. The coded information will go on to 8 different switches. Accordingly, my purpose is solved. Did you see the easiness of here? Just because 3 by 8 combination is done, then the LEDs are glowing. Otherwise, I should have 8 switches to light them. Is that okay? Yes or not?
Yes, ma'am.
Now tell me, what is there inside this magical box? Simple AND gate, na? Don't you think it has only AND gate combination?
Yes, ma'am.
That's all. So decoder is what? Decoder is taking inputs and producing unique outputs so that the unique outputs can further be utilized for an application. Everybody understood?
Yes, ma'am.
Clear or not? So this is how we can use. So this type of systems are already inbuilt. At a max, what we are doing here? See, we are having X. How this denote? If you take here, what can be inside the system? We will have this all and D naught. This is what D naught is coming. Inside is that only. If I elaborate. Correct? So what is D1 having? 0, 0, 1. Oh, I'm so sorry. I'm very bad at this. Right? Not. Correct? Is it correct? Yes or not?
Yes, ma'am.
Yes, ma'am.
Now, yes, somebody has doubt? Now, as a individual decoder cannot be utilized, but decoder can be utilized as a part of a big system. Decoder just like multiplexer, decoder applications are also so many. I have given just an example, right? So where In this one, all the 8 can be utilized. Not mandatory you have to utilize all the 8. But at least my burden is reduced. Did you observe my burden, how much it is reduced? I am having only 3 controls. 3 control variations. But earlier I should have 8 control variations. Is that correct? Yes or not?
Yes, ma'am.
Yes, ma'am.
Yeah, please try to appreciate that this particular topic, decoder, is just a combinational circuit which is very simple. To work out. Okay, but just see the complexity of the AND gate array, because we need a huge AND gate array. Is that correct? Huge AND gate array. Right? Because see, everything is AND combination only, na?
Yes, ma'am.
Okay. Now, since I have 3 bits control things, I have 8 combinations and I gave an application. Now, if at all I have 2 inputs. Okay, my inputs are 2. How many control or distinct signals I will get? 4, na? Huh? What happened?
4, ma'am.
4. Okay. So now that 4 can be utilized for something else. Is that correct? You will agree?
Yes, ma'am.
Okay. Now my question comes here. Because 3:8, it's a simple example I have given. Your task is, hold on. I have a 4 to 16 line decoder. Please try to understand. 4 input to 16 line. Is that correct? The wording is 4 input 16 line. Why? Because distinct lines are coming now. Right? I have to design such a situation. Right? So how complex arrays I should get? Yes or not? How many we will get? Hello? Are you guys there?
Yes, ma'am.
Yes. My combinations will come 4. So you can take W, X, Y, Z. Right? How many outputs? 16 outputs. Is that correct? Now I don't want to waste such a thing. Okay? Right. Please try to rework this 4:16 with 2:4 line decoders. Listen. 2:4 line. Sorry, I'll write here. 2:4 line decoders can be used. Right? How many you can use? Any number. But my output should be distinct 16 outputs. I cannot spend money on this huge IC. I can take small ICs of this size. Are you getting my point? 2:4, n number you take. I have no objection. But I want to satisfy the same thing. Just like your yesterday 16:1 marks, you have got it with small cascaded things. This is the task I am giving you to find out the same thing with this one. Okay, and I'll post the multiplexer posting by tonight. Right, answer. And this one, can you think on this? Everyone, consider 2:4 decoder is available. Our target is to get 16 distinct lines, but I can use so many like this. But your system should be interconnected, not individual. They are all interconnected. See, this is all interconnected network, right? Yes or not?
Yes, ma'am.
Yeah, so that's what. So your decoders, outputs, everything has to be interconnected. Think of a cascaded mode. right? And so that your output should come. Yes or not? So please note down.
Okay, ma'am.
Yeah, design a 4. See, even if it's wrong also, I am there to help you, right? So directly why I am going to a small one. Instead, I can take 3:8 decoder, 2 things and then work out. Right? Okay, that also I can do, but I am going to the minimal one, minimal combination. Right? So please try to take, and now you may fall into some trap that some of the inputs may not be utilized. Just like your don't care conditions might come. I'm thinking. If your thinking process is towards my way, so maybe you will get some don't care, maybe you will converge at some points. Okay, that doesn't matter. Please try to work out. Is that fine? Decoder?
Yes, ma'am.
Yeah. So now even a 2-bit comparator also you can do using a decoder. Yeah, because decoders are like that. We can utilize them. Decoders are regular ready-made ICs. Okay. So distinct outputs we can calculate from decoders and then say, okay, this is a comparator also. Afterwards we will think about it. But anyway, please try to work out this one. Right? So I'll see you tomorrow. Class is done?
Yes, ma'am.
Okay.
Yes, ma'am.
Very good. Now I can hear 2 voices. Salagna, I think. Other one. Right. Thank you. Okay. Tomorrow, I think 2:15. Right.